Hey guys, this video is to help you understand the end of section 1.1 and the circles part of section 1.2. In section 1.2, you're going to notice graphs of equations that you know how to sketch graphs, you know how to identify x and y intercepts, you can do problem solving. What you may not recognize is graphing and writing equations of circles. So I'm going to focus my efforts there, along with one example that was at the end of section 1.1. So if you follow along, this example at the end of section 1.1 was in the slides notes. It's slide number 20. It's an application problem where if you want to follow along, maybe you're writing this down in a notebook. So how do you verify a polygon? It says show that the points form the vertices of the indicated polygon. So in 26, how would I know that these three vertices form a right triangle? Let's give it a little look. Let's do a little quick sketch. As a good problem solver, we'll draw a graph. 3, 5, and 5, 1. So if I form this triangle with these three vertices, I'm writing on my iPad, it's a bit sloppy here. Looks like I have a right triangle. Well, let's see. Let's see if these three legs form a right triangle. So one clue to forming a right triangle would be perhaps you to remember that a squared plus b squared must equal c squared if the two short legs squared and added equal the hypotenuse squared. So if that's the case, I should apply the distance formula. So side 1, I'm going to get right here, this side. If I get the distance, or the length of that line segment, I'm going to square root the following quantity. So I talk to myself and I'm going to subtract the x's squared, and then subtract the y's squared, and we'll get 16 plus 2, that's 20. If I go to get the next leg, let's get distance again. Subtract the x's, 3 take away 5 squared, subtract the y's, 5 take away 1 squared, and looks like I get 16, 4 plus 16 is the square root of 20 again. And if I go to get this third leg, subtract the x's, 5 minus 1 squared plus 1 minus 3 squared, and I'm going to get 6 squared plus 4, that's square root of 40. So let's see, did it quite work out? Have we proven that the sum of the squares of the two shorter legs of the triangle, I know I'm looking in a weird place, but that's the way this particular software works on my iPad. So I believe we've checked 20 plus 20 equals 40. So by the converse of the Pythagorean theorem, this is a right triangle. Okay, now in the next section, it's about, scroll here, you see the title graphs of equations. Let me scroll quickly. I'll just get a little highlighter tool out. And as I scroll, I realize I can't scroll and highlight at the same time. Trust me when I say you know what's in the most of these 20 pages other than the circles part. So as I scroll, I'm just going to talk and convince you that one big idea, if I'm ever asked to find whether a point is a solution to an equation, then that given point has to satisfy the equation. So here's an example of that. Now if I'm asked to graph an equation, I need to figure out a set of all points that solve the equation, but that's a little overboard, so why don't I just get a few points that solve the equation? So you've seen this before, just a point plotting method. Makes sense that you typically write the equation as a y equals something something, right? We usually get a y equals, and then we use the equation to pick some x's find the y's, and then plot the points and connect with a smooth curve. So you already know these big ideas. In fact, you're well beyond these big ideas when it comes to graphing an equation. So if you have to sketch the graph of y equals negative 3x plus 7, it should be no surprise that if you pick a few solution points, meaning you pick a few x's, use the equation to get the y's, as you go through that process with a table of values and point plotting, it should be obvious that you have graphed the equation of a line. Okay, intercepts you also know. In order to get intercepts, you know we're talking about where the graph crosses the x and or the y-axis. So many possibilities exist in this scenario. You could have a y-intercept but no x-intercepts. That's this first picture. You could have 3 x-intercepts and 1 y-intercept. Here's a graph with 1 x and 2 y-intercepts. And here's a graph that has none. So many possibilities exist. How do you actually find those intercepts? Well, you also probably remember that the x-intercept is the value of x that makes y 0, while the y-intercept is the value of y that makes x 0. And we typically denote those with 2 letters of the alphabet, lowercase a and lowercase b. So there's what I just said. Finding x-intercepts, you know how to do that. Okay, an example, if I give you this equation right here with the instruction to find the x-intercepts, well, first, if you put 0 in for y and find x, you have an algebra problem to solve. Hopefully, you know that you solve that by factoring and figuring out that you have roots of 0 and plus and minus 2. So there's the x-intercepts of the graph shown there. If you want to find the y-intercept, that's usually easier. You plug 0 in for x and find y, and in this case, the y-intercept ends up being the origin. So a really simple example. One that maybe wasn't so simple, at least when you first tried, was an absolute value graph. Well, an absolute value graph, again, you have to pick reasonable x's in a table of values so that when you get the y values from the equation, you do end up with points that form a proper graph. So for example, I wouldn't want to just make x 1, 2, and 3. I would typically want to pick some negatives and some positives, but not just any one. Let's use a little bit more advanced knowledge that we would already know. First of all, when we see absolute value, we should get a V-shaped graph. And that V would have its vertex sitting to right 1, so it would be at 0, 1. So knowing that 1, 0. Knowing that, when you pick some good x's, you're going to have a table of points where you definitely have 1 for an x value, plus a few values to its left, and a few values to its right. Once you pick those x's, and then you use the equation to find your y values, then all you have to do is plot the order of pairs, and voila, you have an absolute value graph. Okay, so here's what you don't know. Circles. So in the graph of circles, we have the idea of how could I come up with an equation that represents the relationship between coordinates in a plane and the center, coordinates that are equally distant from a single point in a plane. That would form a graph of a circle. So what you have to do is think about this. If I have this single point in a plane, and I call it the center HK, and I think about all possible points that are equally distant from that, how could I come up with a relationship between the point x comma y, any point on the circle, x comma y, the center, and then the distance between them is the radius. Notice you heard me say the word distance. So all I'm going to do is show you that this is just the distance formula. There's not that much room to write here, but I'll squish it in. If I squished in a right triangle, then this radius r is nothing more than the hypotenuse of a right triangle whose legs would be y minus k, because that's the size of the vertical leg of this triangle. And then the horizontal leg is x take away h. So all I end up with is the relationship that in a right triangle, the square root of the square of the two short legs added up equals the longest leg. So the distance formula basically lays out the relationship that I can now say is an equation of a circle. We don't usually have it in standard form with a radical in it, so if you simply square both sides, you end up with the standard form of the equation of a circle. Okay, so the important quantities in this equation are that x and y are the variables, h and k represent the coordinates of the center, and r the size of the radius. Now there's always special cases. So a special case would be if the circle center is at the origin, then you put 0 in for h and 0 in for k, and you get x squared plus y squared equals r squared in that special case. Okay, so here are the examples that are important to help you out with homework. If I give you this equation and we have to identify the center and radius, well then all I have to realize is that the h would be a 3, the k would be a -1 because the minuses are built into the equation, and I can see that r squared is 16. So that means the coordinates of the center, which are hk, is simply 3, -1, and the radius r would simply be the square root of 16, which is 4. So then if you ask me to graph this circle, it's also a pretty simple task, although it's going to come out kind of sloppy, not on a grid. If I put about 7 ticks in each direction, it should be enough. 1, 2, 3, 4, 5, 6, 7. 5, 6, 7. 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Let's go plot that center at 3, -1. And then all I have to do is count the size of the radius. 4 to the right. Let's go 4 up, 4 to the left, and 4 down. And again, not so neat here. Not so neat, as I said. Is there a backup button? There it is, I think. Maybe not. Let's draw this thing. And again, kind of sloppy, but we took those 4 extra points in, plus the center, and those 5 points are enough to draw the graph of a circle. Well, now what if I give you the information that the point 3, 4 lies on the circle and the center's at -1, 2, and the prompt is to write the standard form? Well, they gave me the center, but they didn't give me the radius. So some prior knowledge just given to you in section 1.1, the radius is nothing more than the distance between those 2 points. So I'll square root the distance between the x's, 3 minus 1 squared, plus the distance between the y's, 4 minus 2 squared. Looks like we're getting 16 plus 4, we're getting the square root of 20. So if the center is at -1, 2 and r is the square root of 20, then the standard equation is x minus 1, so x plus 1 squared plus y minus k squared equals r squared. Voila, the equation of a circle. Okay, and then finally, a little bit more advanced, not in the homework, but we need to know this. What if we give you an equation of a circle right here, and we say get it into standard form? Well, that standard form that we asked for looks like a sum of squares. Well, in order to get a sum of squares, you've seen a process called completing the square. So let's show you how to complete the square to get to the standard form of an equation of a circle. So I'll take that x squared plus 6x, and I'll need a number to complete the square. We'll take this y squared minus 8y, and we'll need a number to complete the square. We'll move 11 over, and then we'll have to add on those 2 extra numbers. Completing the square, half of 6 squared is 9, half of -8 squared is 16. We'll need those numbers 9 and 16 over here. So now I have a perfect square. X plus 3 squared plus y minus 4 squared equals 11, 20, 36. So we've got the standard form of the equation, and now we can get the center at 3, -4. No, let's fix that. Common mistake, right? Remember, when I take the h and k, they change their signs here. So -3, 4, and the radius would be the square root of 36, which is 6. Okay, that's the part of the notes I wanted to have a video for you guys. Hopefully that helps. Press the speed me up button so that you can watch the video in less than the 15 or so minutes it took me to record this.